Hi, welcome back to Math 112. We're going to continue our conversation of conic sections with a discussion on parabolas. Now, we've talked about parabolas in previous classes as being defined by an equation of the form y equals ax squared plus bx plus c. But there's actually a definition of parabolas that is based on a fixed point and a distance. And it turns out that a parabola is the set of all points that are equidistant from a fixed point, f, that we're going to call the focus, and some line that doesn't contain that point, that we label D, that is called the directrix. So every point on a parabola is equidistant between this line D and this point F. The point closest to the focus and closest to the directrix is the vertex. Now, we can define the focal length of the vertex as P, and that's, or of the parabola, as this, it's actually the absolute value of a parameter P. That is, and this P is the distance between the focus and the vertex. So an example of an application of this is if you've ever been in a whispering gallery, they're always parabolically shaped. And anybody that speaks right here, so a lot of acoustical effects happen because of focus points. And if you're in a parabolic room, or if you're looking at a parabolic microphone, or this is also why radio antennas are parabolic, because anything that bounces off of this parabola goes through this focus point. Or if somebody speaks right here at this focus point, the sound will bounce off of the parabola and be magnified. So let's take a look at what this means for us. What it means is we've got a slightly different form of the standard form of a parabola, standard form of the equation of a parabola. If we've got a vertical parabola, a parabola that opens upward, we're going to use x minus h squared is equal to 4p times y minus k. Our vertex is at the point hk. Now, in previous courses, we've used an a here. We're now using 4p because we want to be able to talk about the focal point, or the focal distance, the focal length. If p is positive, the parabola opens upward. If p is negative, the parabola opens downward. We also know that we can have horizontal parabolas, and those occur when y is squared. And so our standard form is y minus k squared equals 4. Again, we've got that p times x minus h. Again, the vertex is at hk. Notice that h always goes with x, k always goes with y. If this thing will open to the right if p is positive, and to the left if p is negative. So let's take a look at the equation of a parabola. We are given the equation x plus 1 squared equals negative 8 times y minus 3. We want to know where are the vertex, the focus, and the directrix. Now we know this is a parabola because only x is squared. We also know that this is a vertical parabola because x is squared. So we take a look at the P, and so this is a parabola that opens downward because we see that 4p equals negative 8, which means that p equals negative 2. Now remember what this p is. This is, so if we take the absolute value of p, that's 2, that means that there are 2 units. So the focus, so this thing opens downward. There's the vertex, this is the focus, this is the directrix. So the focus is right here. And what this means is focus is 2 units below the vertex. And the directrix will be a horizontal line 2 units above the vertex. So we can read directly from the equation that our vertex, remember that this is x minus h squared equals 4p times y minus k squared. The vertex is at hk, which is at -1, 3. My focus is 2 units below that. X coordinate will be unchanged. So it's at -1. 3 minus 2 is 1. Sorry, focus. And the directrix is a horizontal line that goes through the point -1, 5. Or, sorry, that's going to be y equals 5. Now we can check our work on Desmos. So let's take a look here. Yeah, okay. So let's go ahead and graph our equation as it's given to us. So that's x plus 1 squared equals -8 times y minus 3. And I said that was a downward opening parabola with a vertex at -1, 3. There's my vertex. The focus is going to be 2 units below that, so that should be at -1, 5. Whoops, sorry, not right, -1, 1. And the directrix goes through the point -1, 5 because it's 2 units above the vertex, so that's the line y equals 5. So the orange line is the directrix. The blue dot, or sorry, the green point is the focus. The blue point is the vertex, and the red curve describes the parabola. Okay, let's do another example here. Let's write the standard form of the parabola with a focus of 2, 1 and a directrix of y equals -4. Okay. So horizontal line for a directrix. So this is my directrix. This means we've got a vertical parabola. The focus is above the vertex. So my parabola is going to have to open upwards somehow. We know what we're going to write is we're going to write x minus h squared is equal to 4p times y minus k. All right. My focus is at 2, 1. My directrix is at the line y equals -4. Remember that p is the distance between the vertex and the focus, and the focus is going to lie the vertex lies halfway in between these two. So what we really need is the distance between my directrix and my focus, which is the difference in the y coordinates. So that's -4 minus -1 is 5. It's actually negative 5, but we only care about the absolute value. So P is equal to 5/2. And it's positive because the parabola opens upward. We can find the vertex. We actually already know the x-coordinate. That's at 2. And then the y-coordinate is 1 minus p, which is 5/2, or negative 3/2. So my vertex is at 2, negative 3/2. So my equation for this parabola is x minus 2 squared is equal to 4 times p, which is 5/2, times y minus k, so y plus 3/2. So this is x minus 2 squared equals 10 times y plus 3/2. And there we have the standard form of the equation for this parabola. The parabola that has got a focus at the point 2, 1 and a directrix at the line y equals negative 4. Okay, let's go ahead and graph this parabola. We're given that y minus 2 squared equals 12 times x plus 1. We know that this is a horizontal parabola because y is squared. We know that it opens to the right because this 12 is positive. So it looks something like this. We know that the vertex is at the point, 2, negative 1. So it looks more like this. Ignore that. Okay? So what do we know? We know vertex is at the point 2, negative 1. We know that 4p equals 12. So p equals 3. What that means is that the focus lies 3 units to the right of the vertex. So that's going to be at the point 5, negative 1. Yes, y-coordinate is unchanged. So the vertex is here at 2, negative 1. Focus is here at 5, negative 1. The directrix is 3 units to the left of the vertex. So it's going to be at the line y equals negative 1 minus 3 is negative 4. Okay. You can use Desmos to graph this. You can sketch the graph now using plotting points. Okay, so we need to write this in standard form. In order to write the equation of a parabola in standard form, if it is given to us in expanded form, such as this one is, we are again going to complete the square. Now, because we're going for standard form, the first thing we're going to do is we're going to gather all of the terms that include the variable which is squared on one side. So in this case, I'm going to gather my y's on one side of the equation, and I'm going to put everything else on the other side of the equation. Because remember what I'm going for. In this case, I'm going for y minus k squared equals 4p times x minus h. Now, on the left, we're going to complete the square. So this is y squared plus 4y. I'm going to add half of 4 squared, which is going to be a 4. And I'm going to add that same 4 on the other side of the equation. So I have y plus 2 squared equals negative 8x plus 8. Now we factor out on the right-hand side the coefficient on the x. So y plus 2 squared equals negative 8 times x minus 8. So that gives us a vertex at negative 2, at 8 comma negative 2. And it gives us a p parameter. Absolute value of p is going to be 2 because negative 8 is 4p. So p is negative 2. So the distance parameter, the focal length, is 2. Now, what do we know here? We know that this parabola is a horizontal parabola because y is squared. And we know that this parabola opens to the left because 4p is because p is a negative number. But we've got a vertex here at 8, negative 2. My focus is 2 units to the left. So my focus is going to be at the point 8 minus 2 is 6, negative 2. And the directrix, this line D, is a vertical line 2 units to the right of the vertex. So that's going to be at x equals 10. Okay? All right, so I just demonstrated how to convert your equation from expanded form into standard form for a parabola. Here's the written version. As I said earlier, we are going to do some completing the square. So do refresh yourself, practice this. If you have any questions, please do let me know. I will see you all soon. This concludes our discussion of parabolas. Do read the section in the textbook because there's a pretty cool example with, I believe it's with a whispering gallery. Maybe not, might be with a parabolic microphone, but regardless, there is an example there. So take a look at the text, read this section, work on this homework. Have a great day. I'll see you all again soon. In the meantime, do good math.